morning, students. In this lecture, I am going to solve problems on Fourier integral theorem, Fourier cosine integral and Fourier sine integral, students. Let us see the problem. Using Fourier integral, show that e power minus x cos x, that is equal to 2 by pi integral 0 to infinity lambda square plus 2 divided by lambda power 4 plus 4 cos lambda x d lambda, cos lambda x d lambda. Now, if you observe the integration, students, here we have cos lambda x, students. What, students? Cos lambda x. So, you use here Fourier cosine integral. What, students? Fourier cosine integral. Right. Solution. We know Fourier cosine integral. What, students? Fourier cosine integral. What is formula, students? F of x, that is equal to 2 by pi integral 0 to infinity cos lambda x into integral 0 to infinity f of t cos lambda t dt into d lambda. Now, here we need f of t, students. So, let f of x is equal to, what, students? F of x, that is equal to. Now, always take the function which is left hand side, students, like this, e power minus x cos x, students. So, e power minus x cos x, e power minus x cos x. Okay. Now, I want to take the inner integral, students. So, integral 0 to infinity f of t cos lambda t dt, that is equal to integral 0 to infinity f of t, students. What is f of t? Right. E power, you write t in place of x, students, x. So, e power minus t cos lambda t dt, Now, here we have a formula, students. What is formula? 2 cos a cos b. What is formula, students? Cos a plus b plus cos a minus b. Or, students, cos a plus b plus cos a minus b. What is missing term here, students? 2. So, multiply 2 by 2, students. Multiply with 2 by 2. So, 1 by 2 into, write 2 here, students. 2 here. Now, it is like 2 cos a cos b, students. Say here a is lambda t and b is, say, t, students. T. That is equal to 1 by 2 into integral 0 to infinity e power minus t into, come on, tell me, students, cos a plus b. So, cos a lambda t, taking common, students, t. So, we get here lambda plus 1 into t plus cos a minus b. So, cos a minus b. Again, taking common t, students, we get here lambda minus 1 into t into dt. Now, multiply with e power minus t, students. So, 1 by 2 into integral 0 to infinity e power minus t cos lambda plus 1 into t plus e power minus t cos lambda minus 1 into t into dt. Again, I have formula, students, here. What is formula, students? Integral e power ax cos bx dx. What, students? Integral e power ax cos bx dx. What is formula, students? E power ax by a square plus b square into a cos bx plus b sin bx. b sin bx. Again, what is a here, students? What is a? A is minus 1 and b is, students, here b is lambda plus 1, lambda plus 1. So this is complete bracket, students, here. So 1 by 2 into e power ax by, so e power minus t by a square minus 1 whole square, students. We get 1 plus b square lambda plus 1 whole square, lambda plus 1 whole square into a means minus 1 cos bx. So cos lambda plus 1 into t plus b sin bx. b is lambda plus 1. So lambda plus 1 into sin lambda plus 1 into t, bracket close, plus. Now again, what is a here, students? A is minus 1 and b is, this time b is lambda minus 1. What, students? b is lambda minus 1. Again apply the same formula. Students. So e power minus t by a square minus 1 whole square. So we get 1 plus b square. We get lambda minus 1 whole square, bracket a cos bx, students. A means minus 1 cos b lambda minus 1 into t plus b cos bx lambda minus 1 into sin lambda minus 1 into t, bracket close. Between the limits, students, 0 to infinity. So that is equal to, substitute upper limit, students. So 1 by 2 into e power minus infinity. I know e power minus infinity value, students. E power minus infinity value 0. What, students? E power minus infinity value 0. So e power minus infinity. So the value is 0. Plus, again here also we have e power minus t. So that means e power minus infinity. So the value is 0. Now substitute lower limit, students. What is lower limit here? 0. So minus e power 0, 1. So 1 by 1 plus lambda plus 1 whole square into minus cos 0, students. Cos 0 value is 1 plus sin 0 value is, of course, 0. Minus, we are substituting lower limit, students. So minus e power 0, students. E power 0 means we get here 1 by 1 plus lambda minus 1 whole square into minus cos 0. Cos 0 is 1. Again sin 0 is 0. So that is equal to 1 by 2 into minus plus, students. So 1 by 1, expand this, students. Expand this. We get here lambda square plus 2 lambda plus 1 students, plus 1 plus minus into minus plus, again 1 by, we expand the, students, lambda square minus 2 lambda plus 1, already we have plus 1, students. So plus 1. So that is equal to 1 by 2 into, I want to rearrange the term, students, here. Like lambda square plus 2 and here also lambda square plus 2. What happens, students? Come on, tell me here. Lambda square plus 2 lambda plus 1 by lambda square plus 2 minus 2 lambda. Okay, students, what is my idea? This is like a plus b and here a minus b. A plus b into a minus b. What is formula, students? A square minus b square. So simply do it LCM here, students. See, students, that is equal to 1 by 2. What is LCM here, students? What is LCM? Lambda square plus 2 lambda into lambda square plus 2 into, minus 2 lambda. Here we get the term, students, this one. So lambda square plus 2 minus 2 lambda. You have plus here. And here students, we get this term students. So lambda square plus 2 lambda, bracket close, that is equal to 1 by 2 into, see students, it's like a plus b into a minus b. So what is formula students here? Lambda square plus 2 whole square minus 2 lambda whole square. 2 lambda whole square. See students, in the numerator, minus 2 lambda plus 2 lambda cancel. Okay students, now lambda square plus 2 and lambda square plus 2 students. 2 into lambda square plus 2 plus 2. So 2 cancel here students. That is equal to lambda square plus 2 divided by, we expand the students, lambda square whole square, so lambda power 4 plus 2 square 4 plus 2ab, so 4 lambda square minus 2 lambda whole square, so 4 lambda square. So minus 4 lambda square plus 4 lambda square cancel. So we get here lambda square plus 2 divided by lambda power 4 plus 4. Now you substitute, say this is 1 students, this is 1, substitute in 1, we get f of x, that is equal to 2 by pi integral 0 to infinity cos lambda x. What is the value students? What is the value? Lambda square plus 2 divided by lambda power 4 plus 4 into d lambda. Now what is f of x students? What is f of x? E power minus x cos x. See students, e power minus x cos x. So this can be written as e power minus x cos x, that is equal to 2 by pi integral 0 to infinity lambda square plus 2 by lambda power 4 plus 4 into cos lambda x into d lambda, which is our result students, Once again students, you observe cos lambda x here students. If you observe sin lambda x, you are using Fourier sine integral. If you observe cos, Fourier cosine integral. Okay students, you write the formula. You take inner integral students. You evaluate this integration. You find the value like this students. Finally you substitute here. Then you get the required integration value students. Right. Let us see the another problem students. Write down students. Express the function f of x that is equal to 1 for modulus x less than or equal to 1 and 0 modulus x greater than 1 as Fourier integral and integral 0 to infinity sin lambda cos lambda x by lambda into d lambda. Solution students. Solution. What is given students? Given f of x that is equal to 1 for modulus x less than or equal to 1 and 0 modulus x greater than 1. Now see students here. Hence we are evaluating here integral 0 to infinity sin lambda cos lambda x by lambda into d lambda. Now you observe this term students. Cos lambda x. Okay students, cos lambda x. That means we are applying the formula Fourier cosine integral. What students? Fourier cosine integral. Right. We know Fourier cosine integral. What is Fourier cosine integral students? F of x that is equal to 2 by pi integral 0 to infinity cos lambda x, integral 0 to infinity f of t cos lambda t dt into d lambda into d lambda. Now again you take this inner integration, students. Take integral 0 to infinity f of t cos lambda t dt, that is equal to integral. See students, f of t here modulus x, students. So modulus x less than or equal to 1 means minus 1 less than or equal to x less than or equal to 1, students. It is modulus x less than or equal to 1 means. Now what is lower range, students? Minus 1. Minus 1 to 1, the f of x value is 1, students. Minus 1 to 1, f of x value is 1, students. So our lower limit starts from here, students, 0. So 0. What is upper limit, students? 1. So 1. Now what is f of t value, students? 1. Now beyond these limits the function value is 0. Beyond the limits the function value is 0, students. So f of t value is 1. Simply cos lambda t dt. So that is the equal integral of cos lambda t, students. Simple. Sin lambda t by lambda between limits 0 to 1. So that is the equal, we get here sin lambda by lambda. Sin lambda by lambda. So this is 1, students. Substitute in 1. Substitute in 1. We get f of x, that is equal to 2 by pi integral 0 to infinity cos lambda x. This integration value, students, sin lambda by lambda. So sin lambda by lambda into d lambda Now see, students, we are expressing this function into Fourier integral, students. Fourier integral. Now we have to find this integration value, students. For that you cross multiply 2 by pi, students. So that implies integral 0 to infinity sin lambda by lambda into cos lambda x d lambda, that is equal, students, pi by 2 f of x. Pi by 2 f of x. That is equal to. See, students, f of x. What is f of x, students? Modulus x less than or equal to 1, students. Modulus x less than or equal to 1. So I want to take here modulus x less than 1, students. Modulus x less than 1. What is the value, students? 1. So f of x value is 1, students. 1 into pi by 2 is pi by 2. 1 into 2, pi by 2 is pi by 2. So modulus x I want to take greater than 1, students. What is greater than value? 0. So 0 into pi by 2 is 0. Now see, students, at modulus x is equal to 1. Now where is the discontinuity, students? At modulus x is equal to 1. At modulus x is equal to 1. That means here at x is equal to 1 and at x is equal to minus 1 are discontinuous points, students. Are discontinuous points. So at x is equal to 1, discontinuity. Right. Whenever there is a discontinuity, we have a formula, students, like f of 1 minus 0 plus f of 1 plus 0 divided by 2, students. 2. That is equal to f of 1 minus, students. See here, we know here minus 1 less than or equal to x less than or equal to 1 means the x value between minus 1 to 1, the value is 1, students. So 1 minus. So it is lies between minus and 1, students. So the value is 1 here. Plus 1 plus, students. 1 plus. Beyond the 1, the value is 0. So 0 divided by 2, students. So that is equal, we get here 1 by 2. 1 by 2. Now yet x is equal to minus 1 also, there is a discontinuity, students. Discontinuity. So this time, students, f of minus 1 minus 0 plus f of minus 1 plus 0 divided by 2 students, that is equal to minus 1 minus 0. Okay students, minus 1 minus 0, that means it doesn't lies between minus 1 to 1, so the value is 0, plus minus 1 plus students, minus 1 plus, that means the value lies between minus 1 to 1, so the value is 1 students, divided by 2, that is equal to 1 by 2. And both cases the value is 1 by 2. Therefore f of x value students, f of x value 1 by 2. So 1 by 2 into pi by 2, 1 by 2 into pi by 2, pi by 4, pi by 4. This is the value of the given integration students. Now once again students, he given a function and says that for express into Fourier integral, and he given a integration students, find the value. So I am observing this, first I am observing this integration students. There we have a cos lambda x. So when there is a cos lambda x, it is a Fourier cosine integral. Or students, it is a Fourier cosine integral. So write down Fourier cosine integral formula. Now first take inner integral. Evaluate this integration students. We get this value and substitute the value here students in 1. We get f of x, that is equal to 2 by pi integral 0 to infinity cos lambda x sin lambda by lambda into dt. This is the Fourier's integral of the function. Now what he says students, integral 0 to infinity, evaluate this integration. I am taking these two are same students. By cross multiplying we get pi by 2 into f of x. Now I observe f of x students. There we have a modulus x less than or equal to 1, modulus x greater than 1. I am splitting into modulus x less than 1 and modulus x greater than 1 and modulus x is equal to 1. Clearly modulus x less than 1 means its value lies between minus 1 to 1. Clearly it is, the value is 1, so we get pi by 2. If modulus x greater than 1, clearly f of x value is 0, so value is 0. And modulus x is equal to 1, there is a discontinuity at 1 and minus 1. 1 and minus 1. So I am finding the value, both values are same. So modulus x is equal to 1, the f of x value is pi by 2. F of x value is, f of x value 1 by 2. So 1 by 2 into pi by 2, pi by 4, pi by 4. This is about the problem students. Hope you understand. Thank you for watching this video. Jai Hind.